Hey guys, this is Christian Clark with my Zika virus presentation. As we know, mosquitoes are a very abundant insect on this planet that cause various diseases. You can follow along here. Some mosquito-borne viruses include malaria, which causes fever, chills, headaches, sweats, fatigue, nausea, vomiting, and if left untreated, even death. There's also the West Nile virus, which causes fever, headaches, skin rashes, stiff feeling in the neck, sleepiness, disorientation, coma, tremors, paralysis, convulsions. There's also the dengue virus, which causes severe headaches, joint, muscle, and bone pain, rash, and mild bleeding. And lastly, there's the Zika virus. The Zika virus causes fever, rash, joint pain, and conjunctivitis. Many times the virus goes undetected, but the consequences it has on pregnant women poses a very dangerous risk to babies, their offspring. So women who are bitten by an infected mosquito or come in contact with a male sex partner can give microcephaly to their offspring. Microcephaly is a condition in which babies have birth defects because their head size is smaller than that of a normal baby. Some symptoms, like if you have a birth defect or microcephaly, can include seizures, developmental delay, like problems with speech, developmental milestones, like delay with developmental milestones, like sitting, standing, walking, intellectual disability problems there's also intellectual disability problems with movement and balance, hearing loss, vision problems. There's also feeding problems, and that can be like swallowing. These aren't the only viruses that mosquitoes can transmit, but mosquitoes actually kill more than 1 million people each year. So through all these diseases and viruses, we can tell that mosquitoes are very dangerous. So the question we can pose is, how do we stop these mosquitoes? Well, we have many options to stop these mosquitoes from causing harm. For example, we have organophosphates, which are adulticides, and they are inhibitors that disrupt the mosquito's nervous system and can be used after outbreaks. We also have, they can be used after outbreaks, but they can be harmful to humans and animals where they have unwanted effects on them. We also have larvicides, which are bacterium put into water that is used to kill larvae or young mosquitoes by gutting the stomachs of the mosquitoes, causing sepsis and even death. And it can also have unwanted effects if ingested, like the water with the bacterium in it. Lastly, there are repellents, which can be used by humans, and these they can disrupt or kill the mosquitoes before they can detect or bite the human. But the problem is that the mosquitoes develop resistance to these chemical strategies. So often we have to come up with newer and more sophisticated strategies to deal with the mosquitoes. So the reason, you might be wondering why they become resistant. Well, the reason they're able to develop resistance is because the life cycle of a mosquito is very short and they can mutate quickly to become resistant to the chemicals that they are treated with, especially if the chemicals or pesticides are overused. In fact, annually the US spends approximately $80 million on mosquito control products while generating approximately 1 billion retail sales on repellents each year, with an expected 50% increase this coming year. And the reason they spend $80 million each year is because they try to find new ways to kill the resistant mosquitoes. And also the reason for the dramatic increase expected in the sales this year accounts for the growing tension from the Zika virus. In fact, as of February 17th, the CDC, or also known as the Center for Disease Control, has reported over 80 cases of the disease in the U.S. and it has come to many people's attention that as the summer months approach, there needs to be a protection from the Zika virus. Also, the Olympics in Rio de Janeiro this summer will be a threat as many people travel to Brazil, where the outbreak of over 1.5 million cases have been reported. There's also a threat of where the mosquitoes tend to thrive. This poses a worry for the people because they often tend to thrive in urban environments and breed in small pools of water. So if they're breeding and thriving in urban environments where the population is very dense and high, and mosquito populations are very thriving and their populations are very high, then it kind of makes sense to say that a lot more people will get infected and possibly get infected with the Zika virus. So the worry of spraying or dealing with all these mosquitoes is that some may already be resistant to the chemical and some may become resistant to the new chemicals introduced to them. The only logical solution to the problem of effectively removing resistance, preventing resistance, and actually killing the mosquitoes resides in a mechanism known as permethrin. The way that the only logical solution is permethrin with fatty acids such as octonic, nononic, and decanonic acids, fatty acids. The way that this molecule works is the mosquito comes in contact with the repellent. The repellent then uses the fatty acids to knock down the resistant barrier that the mosquito has. The permethrin then kills the mosquitoes at a very high rate. The revolutionary discovery by Valent bioscientists suggests this new way preventing mosquitoes from attacking us before they attack, preventing mosquitoes from attacking us. The Valent team did an experiment in which 50% of the resistant mosquitoes that came in contact with the repellent died after 3.2 minutes, compared with the 5.3 minutes it took the non-resistant mosquitoes to die. So the fatty acids, the octanoic, nonanoic, and decanoic fatty acids, these are not actually lethal enough to kill the mosquitoes, but they are able to do a very important job, and that is remove the resistant barrier the mosquitoes develop from past pesticides. So this is very, very important because the reason is because the fatty acids can allow for the future reuse of pesticides that were used in the past but proved not effective anymore on the mosquitoes, for the mosquitoes actually grew resistant to those pesticides. Not only is a repellent lethal to kill the mosquitoes, but it does actually basically no harm to humans. There's mild to no side effects at all. The only downside is it's harmful to cats and fish, basically. So that brings me to my next topic, which is the pros and cons of permethrin. So some pros: it is a very effective way of killing mosquitoes. It kills them at an alarming rate. It removes the resistant barrier, as said before, that mosquitoes retain from past insecticides, pesticides, and it allows for the reuse of past pesticides. It is very easily to apply. It's very easy to apply. It's actually a cream that you can put onto your your clothes or your skin. It also kills mosquitoes very fast. It doesn't take a while for them to die. There are many other different uses, which I will get to later, and they are also not harmful to humans. There's mild to no side effects, as stated before. Some cons: well, it's only used as a repellent, so this means that it can't be sprayed or applied universally to kill mosquitoes. maybe something like an adulticide, which can be used like during outbreaks and sprayed from planes to helicopters. And it can be brought down on mosquitoes and kill them. And it is also harmful to cats and fish, but that's not a very alarming con of permethrin. Some uses, as talked about earlier, it is used by applying cream to the clothing or skin. It is used by the U.S. military, so you know it's official. It is used to kill scabies, a contagious, intensely itchy skin condition. It is used in agriculture a lot to protect crops. It is also used in agriculture to kill livestock parasites. It is also used in timber treatment and the textile industry to prevent attack of woolen products from insects. Lastly, it is used in pet flea preventative collars or treatment. Some future references or future uses. It can be used to remove resistant barriers on mosquitoes and allow for future use of pesticides that were proven ineffective after being applied many times. And a little C-push history of permethrin. Well, in 1979, it was first registered for the use on cotton. From 1982 to 1989, more than 55 crops were approved for the permethrin to be used on. And in 1985, a data call-in for ecological effects was issued for permethrin, and in 1994, producers of products containing the permethrin for use of cotton was requested for voluntary cancellation, and from 1994 to 2000, extensive tests were done on the product for agricultural re-entry, which was then issued to them. So, I did not mention this earlier, but the molecular formula for permethrin is carbon 21, hydrogen 20, chlorine 2, and oxygen 3. And as you can see on the bottom here, this is the molecular structure. It may not seem that all the areas where there's supposed to be carbons actually fill their valence shell, but ultimately there will be, if there is not, usually there's 3 bonds instead of 4, and attached to a carbon bond where there's not 4, where it's not a valence electron, is a hydrogen. That's why there's so many hydrogens here, and you don't really see them kind of included in this diagram. So that is it, guys. That is why you should choose permethrin. It is pretty beast, and hopefully we can see it in the future.